Good morning all, I hope you're doing well. Hello to Lawless from Poland, and hello Stormy. Lawless, you made me realise that the Windows emoji keyboard does not have the flags on it. I was trying to type out hello from Australia flag, but there are no flags on the Windows emoji keyboard, which is the one that I normally use. So that's a bit tragic, but hello from Australia. Yeah, this week was really good, actually. I am very happy with it. After last week's frustrations with everything, this week was so clean, so easy. It's really making me appreciate how smooth and easy things can be when you actually know what you're doing, which is a very nice change of pace around here. But yeah, so I'm very keen to show you what I've been up to. So let's get right into it. We are getting ready to finally measure the legs. Unfortunately, we are not able to actually measure them just quite yet, but we're very close. We just need to wait for a couple more things to arrive. I need some more bits. So the first thing for this week is that the integrated circuits that I was talking about last week worked perfectly. Like it was just clean, easy. Like there were literally no issues. I just followed the data sheets for how to wire them all up, and I obviously made sure to take my time doing that, but it just worked. It was great. So for context here, what I was dealing with is I have a linear slider, which I can actually show you. It's not in that view. I've got a linear slider, which you'll see soon, and I'm using that I want to use that to measure how long the legs are. And the linear slider that I have that's really long, I have a 1 meter long one. That data, I actually don't know if I mentioned this last week. Let me start again. So I have a short linear scale, which you can actually see on, I need to get used to my views, here. So it's the one that's like hooked up to the leg here. That is only 550 millimeters long, and that works. Like the signal that I get from that is clean, and what I was doing last week over like the serial port was fast enough to keep up with that movement. So even if I moved that slider kind of quickly, the Arduino would still keep up. I do have a longer slider though, which is currently out of every frame, so I can't show you. That slider is 1 meter long, which means I can measure the entire length of the full leg, but it has 1 micron precision, which is fantastic, except for the fact that because it is so precise, if I move it at even like a reasonable rate, it's an absolute torrent of signals. And what I was doing last week, the Arduino that I was using had no chance of keeping up. It was way too slow. I do think I mentioned this last week actually, so apologies for the repetition. But yes, so that, and also that signal was very noisy as well. Like, it wasn't just nice, crisp, clean square waves as it should be. So I needed to clean that signal to make it nice, crisp square waves, and you'll see exactly what I mean in a sec about that noise. And then I also had to change that voltage down from 5 volts down to 3.3 volts so that the new microcontroller that I was using, which is a Teensy, didn't break, because that can only take 3.3 volts as an input, but the linear slider can only operate on 5 volts. So it's a whole thing. But suffice to say, it all worked perfectly. So I have the 74HC14 Schmitt-Trigger to clean up the signal, and a 7407 buffer with open collector outputs to rescale the signal to be whatever I want, but I'm using it to go to 3.3 volts. So let's have a look. Let's see what all this is about. So I want to go to here and go to here. Yeah. Actually, no, let's stick on this. Love a good desk cam. Yeah. I want to... Oh, so it's tricky to show everything at once. But yeah, so this is my setup here. This is obviously not how I've actually implemented it in the real deal. This is like a dummy example so that I can use my Oscilloscope to show you how it's all set up. But the end result is that we have a linear slider which is just out of the frame. Maybe I can zoom out a bit and we can see it. There you go. This guy here is a linear slider. This can move around. And then those signals go into there's 2 chips on this board here. Let me zoom right in so you can see them. I'm going to use my little lobotomy screw to point things out. This first one is the Schmitt-Trigger that cleans up our signal, and then the second one will scale it down to 3.3 volts. What I'm using right now to scale this is, here I have a buck converter which, if I can point to it straight, which converts the 5 volts down to 3.3 volts. In the actual setup, which I have here, which is much cleaner, look at this nice little box, so good. I'll talk about this in a sec, if I can open it. It's the exact same thing that's in here, just made on a breadboard. So here, the first one is the Schmitt-Trigger, and then we've got the open collector, the buffer with the open collector output. Cool, so let's have a look. Just realizing I want to have this, and I want to have this. Let me just quickly, how good is that? So let's make this big, and let's get rid of that crop. Okay, so I'll get rid of me as well, actually. These views are sometimes a bit tedious to set up. I guess the most important thing is the oscilloscope. So let's keep that there. And actually, I'll zoom out on the camera so you can see the slider, so you can see when I'm moving it around. There we go, that should work. Okay, so these are data. This is data that I took before, so let's ignore that. And let's only look at signal 1 first. So signal 1 is our just raw output straight from the linear slider. And as I move this around, if I start a trigger, let me... Here, look at that. Terribly noisy. Those top parts are not at all as clean as we would like. This should be a nice, crisp, square, up, down, up, down, up, down. So this is no good. But if we turn on channel 2, which is the output from our Schmitt-Trigger, we can run again. And look at that. That is much, much cleaner. There is still a little bit of noise on the, like, when it's actually on the flats, and I don't really know what's causing that, but the overall, like, steppiness is so much better. I can put me back on top. There we go. Yeah, cool. You will also note that this has inverted the signal. So previously when it was up, and even though it had that weird step in it, it's supposed to just be solid on the top. Now the purple signal is down the bottom, and vice versa. So when the yellow signal, which is the raw output, is down the bottom, our purple signal is at the top. And the reason for that is because this, whatever it's called, the HC14 Schmitt-Trigger, is also inverting, so it will flip my signal around. For me, that doesn't really matter too much because I'm putting both the A and the B channel through the exact same process, so they're both getting inverted. So it really doesn't matter that much. Like, if I was being really rigorous with paying attention to which signal, like the order in which the signals were coming through, then this would potentially cause an issue with the direction. So I would be like reading if I was moving the slider to the right, if I was being really like going from first principles and I forgot about this inversion, then I would be predicting that it was going to the left. But it doesn't matter for me because the direction doesn't, like I know what direction it's going in all the time. So this inversion is not a problem for me. And I also could just put it through again, through the exact same chip, and it would just re-invert it a second time and clean up any residual little mess, which there isn't any, but yeah. So it's not that big of an issue, but it is just, yeah, flipped around. But we'll see, we can still see that this is still at 5 volts. So the top and the bottom of these signals still span 5 volts, which is fine, but that would break the Teensy. If I tried to put this signal into the Teensy, then yeah, gone. Lawless is saying that noise might be from the power supply. Very possible. Yeah, I'm learning through this process. I've learned that my power supply is actually not quite correct. When I set the voltage to be a certain level, the actual voltage coming out is a little bit higher than what the number says on the little screen, which was so confusing because I was trying to get like 5 volt, and then I was trying to figure out basically like a voltage divider so that I could turn my 5 volts into 3.3 volts so that I didn't break the Teensy. And no matter what I was trying, it kept reading out like 3.8 volts. And I'm like, ugh. All the data sheets online say 3.6 volts is like the maximum that you should be putting in. I'm like, oh, it's just 0.2 volts. Like, is that going to actually be a problem? But yeah, only after like a lot of tracing back up the line did I realize that it was coming directly from the power supply. So when I was setting it to 5 volts, it was actually like 5.4 or 5.6 or something like that. So yeah, you're entirely right that like this very possibly could be from the power supply. But in any event, it doesn't muck up the reading of the signals, so I'm not too worried about that. But yes, so our final stage is through the, what is it called? The 7407 buffer. And this basically just scales the output to be whatever I want. So I was, here I've got it set up to scale to 3.3 volts, which is what it actually is in my real board here. But this can go up to anywhere up to 30 volts. So I can scale up and down my signal however I want, which in my opinion is very cool. I think it's very interesting. So we can take another reading here. So if we stop this as we go, boom, there we go. We can see the blue line is identical to the purple line, which probably does suggest the noise is coming before these chips if they're both identical. But yeah, we can just see it's exactly the same, but it's been scaled down to now there's a maximum of 3.2 volts, which you can see down the bottom in the blue here. Yeah, so all of this circuitry, which is a bit of a mess, especially when I have it set up as a little breadboard demo thing here. It's very messy, but it works. And I'm sure I don't have to tell you guys how satisfying it felt when I wired everything up. I'm like, yep, all the power's a power, all the ground is ground, this should be fine. I just turned it on. I'm like, holy crap, it worked. It was such a relief. And then, yeah, converting it over to this board was pretty time consuming, but a little bit satisfying. You can see I got a little bit lazy. I was trying to make my wiring all nice and clean and crisp, but I got a little bit lazy at the end. And I'm just like, nah, whatever. I'm just going to make these wires like jump over the circuit. I don't care. I got a bit over it. But yeah, this box is so good. I'll show you the cat of it and listen to this. It's so satisfying. For a long time, I was debating how I should set up the lid on this. What I really wanted was a nice perspex screen over the top so that I could actually see the board on the inside. But unfortunately, I don't have any perspex of the right. Well, I've only got like super thick perspex, so I didn't want to deal with that. Then I was like, oh, I can do screws, and screws are very easy, but like it's a bit lame if you can just like see screws on the box. But then I eventually committed to using magnets, and I have no regrets because look at how clean this box is. It's just like one input for the CAN bus, which I'll get to in a sec, and the other input for the linear slider. So good. I'm a fan. Yeah, cool. So overall, I have zero complaints about any of that. It just worked so cleanly. It was brilliant. And now, so previously last week, when I was doing everything of a serial, there were big issues with getting everything to sample at a remotely fast rate because printing things to the serial bus, even I think I was doing it at 20 hertz. Even then, I was getting a lot of like misfired signals over the serial bus. Like things would be like half of a line and then they would print. And then there would be like the second half of the line would print as a second instance. And it was just really, really messy. But now, because also in this box, I have that little blue chip off to the side there is a CAN transceiver. So now this can connect to the CAN bus. So I can sample everything at 1000 hertz, which is nuts. And I actually genuinely don't know what the limit here is. All that I know is that 1000 works with no issues. I'm kind of tempted to see how much further I can push this, but then also 1000 hertz is an absolute shitload for what I'm doing, and I don't know, like going down the rabbit hole of like seeing how fast I can go is not really useful right now. But I'm curious to know how fast it can go. So right now, yeah, I haven't actually implemented the recording of the commanded position, but I can fairly easily, I believe. But I am measuring the motor position, measured by the O drive, and then also the measured linear position, which we're using. I've been calling this my data acquisition device, my DAC. So this can tell us the measured linear position. And this is all through CAN. Of course, this process was not without its problems, and there were some funny things that happened. One of which, yeah, the biggest one was that for Teensy 4.0s, as far as I'm aware, it says on, actually, let me get the little sheet. So when you buy the Teensy, you get this little like sheet with various information on it. And one of the things that it says is, here if it will focus, cut to separate V in from V USB if using battery or external power. And I'm like, cool, that's me. I am using external power because I don't want to have to keep this plugged into USB when I'm using it. So I'm tapping into the 12 volt line on the CAN bus, stepping that down to 5 volts with the buck converter, the same buck converter that I was using before, but now it's going from 12 to 5. That's powering the Teensy and the integrated circuits. And then I'm using the Teensy 3.3 volt line to step up the buffer outputs. Yes, so I made that sever. I cut this thing that it says to cut on the back of the sheet here. But the problem with that is that when you do that, that completely separates the USB power from the rest of the chip. So the Teensy will no longer receive any power whatsoever from USB. I believe the intention of this is that if you are powering it from external power at the same time that you have a USB plugged in, then you should cut this thing. So that way you don't have like a weird loop going through your external power and your computer power. But if you're powering these separately at all times, then you should leave it uncut. Because what happened with me is when I cut it, that means that the Teensy can only ever receive power from like an external power source. It can no longer receive any power at all from the USB. And if you see how this is mounted in here, I deliberately didn't put a USB port because I'm like, oh, I don't need to do that. That's not very clean at all. But what this means is that if I take the Teensy out, which I want to talk about in a sec, if I take this out like this and I plug this into USB, it's not going to get any power and I can't reprogram it. So I have to power it with external power while I'm reprogramming it. Thankfully, let me actually go back to this. Thankfully, I have these super long extendo headers and I was able to do this so that it could still receive power and I could plug it in without having to cut a hole in my nice box. Which is a bit dodgy, but, you know, it works. Yeah, one other thing that I want to just quickly mention is that something that I used to not do at all is I would directly, well, something that I used to do was I would directly solder my microcontrollers into the rest of the board that I was using them with, which is fine. That's a very, very solid connection. But the problem with that is that if you ever want to use that microcontroller for literally anything else, it's now stuck in there. When I was first doing this, I was like, oh no, it's okay. I can just unsolder it and then remove it and then I can use it on other things. But if you've ever tried to, the only reason you would think that is if you've never tried to desolder this many pins from something like a Vero board before, because it is freaking impossible. If you have like more than like 3 pins soldered, it is impossible, in my opinion. It's obviously not, it's very, very difficult to get that board out of there. So I strongly, strongly recommend using these sort of header pins, and that way you can just plug it, and then I can plug this in here and leave this in here anytime I need to use this. But then if I want to reuse this Teensy for something else, I can just take it out and there's no issues. It's super easy to remove. Big recommend to do that. Stormy says, I used to hate soldering headers and then I ran into this exact situation and realized, yes, this is why pin headers exist. Yep, I have been through the exact same process. Yep. Cool. So, yeah, all things considered, this board went together pretty well, and I'm very happy with it. And so yeah, actually, I want to show you what this looks like now with it all set up. So I have, oh my goodness, it's 8, isn't it? Yeah, it's 8. All right, so let me plug this in, and then I'll show you through this sequence, and then we will see what the problems are with the current setup, which will be immediately obvious straight away, and then we can talk about that a bit. But yes, let me plug this in. And actually, yeah, while plugging that in, I was just reminded of another issue. Well, it wasn't so much an issue, but a short-lasting roadblock that I ran into while getting all this set up, which was that I wanted to use as much of like the CAN infrastructure that I already have on the robot, so that I didn't have to like rewire any cables or anything like that, because that stuff takes a while. But my God, because those CAN cables are so inflexible, getting this all, just like finding a way that I can tap into the CAN bus without having all of the extra motors involved. So it's basically just like the Jetson straight to the O drive that's going to be powering the leg, and then to my little DAC board that I just had. just having the 3 of those was not trivial to figure out how to actually like physically position all of these things because those CAN cables are so inflexible. And that was like, yeah, more work than it should have been to get set up, but it's fine now. So I was going to show you, I'll show you my VNC view in a sec. So let me boot everything up. I don't know if the camera just flicked for you as well, that was a bit weird. And yeah, I'll show you my code in just a sec, but let me run this for now. The first thing that it will do is run the encoder sequence and then home, which it's already done, it's very fast. It then runs up to the max position that I set, which is 4.1 revolutions, hangs out there for 3 seconds, and then goes back down. And you can probably see the main problem that I have with this current setup, which is that it is wobbly as it is not remotely solid. So let's have this go through. I believe there's one more. Oh no, that's it. Yep, I just went through 2 cycles this time. Okay, so we can turn the noisy fans off, and then let's go to here. Look at that, first try. Okay, so this is all the feedback from that run that we just did. It's just going through its different steps. Kind of, I don't know, maybe useful things to point out here is that I can set what the maximum position is in revolutions in the actual in all of Jugglebot's code so far. I've been using 4.2 revolutions as the absolute limit. It turns out the actual, like, if I'm running the leg right to the very, very top, it's like 4.201 or something like that. So I am trimming that back in all cases down to 4.1, just so we have a little bit of headroom on the top with no, just to make it a little bit less likely to collide. I can set how many cycles I want to do. I can set how long I want the thing to wait for, the velocity and acceleration limits and whatever. And then, importantly, the sampling rate. So right now I have that set to 1000 hertz, which is crazy. So fast. And then I've got pretty much the exact same data analysis script as before. So let's see how that run that we just did went. And so the first thing we can see is that, again, the data is not scaled to be the same because the red line, which is the linear slider position, is measured in millimeters, and the blue line is measured in revolutions. And you will note how clean this signal is. Look at that, it's just perfect, no noise whatsoever. All of that like filtering business that I had to do with last week to do the serial, all of that's just gone. And not only that, we have data at 1000 hertz. It's nuts. So yeah, this first step is just to line up the zeros. So now our 0 points are perfectly lined up for both data sets. The second step is to, this is I haven't really changed this code at all since last week. This is purely just to visualize the run for now. I'm not actually deriving any like takeaways from this, but this is scaling the data based on the absolute maximum of the red line and the minimum of the red line, and then the maximum of the blue line, minimum of the blue line. We're scaling those so that they are identical. And you can see, again, there's a bit of an offset here. And to be honest, I don't really know why this is happening. So like the red line is consistently earlier than the blue line. So our measured linear scale data is coming in sooner than the motor position data, which, oh, actually, no, you know what? I think it's because I shifted everything manually earlier. I don't know where I did that. At some point in the code, I have shifted everything because previously we needed to add this shift. I don't know where that is. Lol. That's probably why. But anyway, that doesn't really matter too much for now. Yeah, so when I was doing the serial data, I did have to shift it because it was actually coming in a bit offset. Now, I believe that this offset is because of that. But you will notice other things as well. Like, for example, even though this is recording at 1000 hertz, the blue motor, the actual measured position of the motor, shows this little dip here that the red line does not. For reference as well, this little dip, I believe, I'm fairly certain, is because what I'm getting it to do is when it comes down, it's not just like moving down to 0, but instead it's actually going through the homing process again. So it will run down until it hits that foam end stop, and then it will stop. So I believe what's happening when this little dip here happens is that it's coming down, it's hitting the foam, presumably at 0, it continues going for a little bit, squishing the foam until the current spikes, and then it says, whoop, okay, let's go back up, and then it goes back to 0 or thereabouts. And that's one of the things that I want to measure here, is how repeatable is that process. And yeah, so we would think that if everything was perfectly mechanically linked together, then the blue line and the red line should be showing all of these little bumps and wobbles and stuff exactly the same. And we can see, in fact, there are a couple cases where this does happen, like some weird step happened there, and both devices picked that up. But this, they didn't. And I believe that's because of a key word that I said in there, which was that or a key phrase, which is that if everything was perfectly mechanically linked, then we would expect to see all these little bumps carry through. But as you could see in that recording, this is not remotely perfectly mechanically linked. And I can show you how I know that, like this. So this, we can print off the CAN readings, and you can see if I go, how can I show this? Let me do this, and this, and this. There we go. So you can see those. Let me just put it over me. If I go over there and I wobble the thing around, you can see that these numbers will change a bit. Hopefully it's obvious. It's a little bit hard to see with so much data coming through. But if I turn off like the motor feedback data, for example, and then so it's only like one set of data coming through, like just wobbling the thing side to side does actually change the readings for both the motor position and for the linear position. So that wobbling is no good, no good at all. But I'm not too worried about that for now, because I obviously need to change it quite a lot. And I'll show you what I'm going to do in a sec. Stormy says, depending on open cell versus closed cell foam, you can end up with a situation where the foam squishes more after being recently squished, whereas springs do not suffer from this. I.e., the foam doesn't fully expand immediately after being compressed. That's interesting, actually. Yeah, that is very interesting. So that could mean that my testing here, where I'm having to go through that homing sequence multiple times in fairly quick succession, is potentially not representative of when it actually goes through the homing in normal operation, because it only does that homing once and that's it, and it won't home again for like, I don't know, another day or so. That's a good point. I wonder if there's an easy way for me to measure that. I don't know. Yeah, something to think about. And Stormy says, in other words, your first cycle might be correct, and then each repeated cycle throws it off more and more. Springs are much more repeatable. It's going to be tricky to retrofit springs in there, and I'm not too keen to modify these actuators too much. But you're definitely right. There is, I believe, yeah, actually, so on this note of homing and like repeatability, if we do what we did last week, where you can we zoom right into this bottom line, we can see that the homing is not coming back to the exact same spot every time. So it starts off at 0, nice and fine, but by the second run, according to the linear slider data, which is the red one, it's not Arduino. Oh, I'm blocking the legend anyway. Yes, the red one is the linear measured data. That one comes back to a millimeter above. The blue line comes to, what is that? 0.06 millimeters below. And then by the third time, the red line's even like both of them are even further off. So this, as it is, like just looking at this raw data, it does look as though the homing sequence is not perfectly repeatable, at least within a millimeter. However, again, I'm not too worried about this right now because of how poor the mechanical linkage is between both of the components. So yeah, I'm not too worried about this right now. I think once I rigidify everything, and I'll show you what I'm going to do with that in a sec, once I solidify it all, I think that these problems should go away. And if they don't go away, then that is cause for investigation. And yeah, so we can see the error is huge, but that error is just taking the position of each one and subtracting them both. So because of this like horizontal offset, that error is not correct. Like we can see, like humans can see pretty easily, okay, this is probably pretty clearly going to link up with this, and these should be directly over each other, but there's some like horizontal offset by quite a lot actually. So what is that? That's like 210 up to 205.5. No, sorry, I was looking at the Y. 11 and 10.8. Yeah, I think that's because of that offset that I applied in there. Somewhere in here is like a minus 0.125. Here it is. I found it. All right, let's see what this looks like with no offset. This should be much more lined up now. That was convenient that I saw that there. Yeah, okay, that's much. Let's look at the error one actually. That's much nicer. But even still, we just see quite a bit of error, like up to 8 millimeters, which is no good. Yeah, there's a lot to look into here. But to be honest, I don't want to get too into the weeds on that because, like, that's not. What is going on? Because this is not representative of what it's actually going to be like once I get it fully set up. So yes, there are still some improvements to make. So let me show you what they are. The first problem is that I'm using the short slider here. I want to use the long slider so that I can actually measure the full length of the entire actuator. I could, like the sliders have the exact same geometry except for their length, so I could just swap out the short slider for this long slider, but as you can see by my connection down the bottom, that little white printed bracket with like the 2 bolts sticking out the end, that, I mean, to be honest, right now that's only actually attached with 1 screw down onto the base plate, but that's a whole thing. But it's just so small. Like, there's no way that can support that entire like 1 meter lever arm against any movement at all. Like, it's not strong enough. So instead, what I'm going to do, what I'm waiting for now is I've bought this. I should have bought a 1 meter length, but I wasn't paying attention properly, and I bought a 1.5 meter length. So we've got a bit of headroom here of a C-section aluminium extrusion. This has not arrived yet, but thankfully, aluminium extrusion is always the same geometry, so I can pre-CAD things to get it all ready. So that C-section will hold our aluminium linear slider using these little end brackets here. So this will be attached with 4 bolts on that end and 4 bolts down the bottom end. It's the exact same thing. And then we've got this giant bracket here to hold everything. I'm debating whether this is tall enough to support the entire thing, because this is like up to the very, very top is going to be 1.5 meters. So it's going to be a fairly intense lever arm trying to push this around. But my plan is to print this guy out of nylon carbon fiber. So I think it should be pretty strong. And it's probably going to take a while as well. But yeah, I'm debating whether I should make it taller or not. For reference, this is 85 millimeters tall, which feels pretty tall. And like, if I put in all of these nuts and bolts, that's going to be pretty solidly attached in there. So I don't know. Of course, I haven't actually printed this out yet, so yeah, I'm more than able to make changes if anyone's got any suggestions for how to make that a bit stronger, if it needs to be stronger. And yeah, so then at the top here, attached onto the linear slider itself, will be this bracket. And I was umming and ahhing for a while about how to best attach this to the legs, but I think ultimately the best way to go is just directly like this. So there will be, well, there is, I've actually reprinted that part out. There's a hole in here. I possibly will change this to make it some kind of ellipse so that if things aren't perfectly lined up, I still have a bit of wiggle room, because I'm skeptical that everything is going to be perfectly lined up. So yeah, I may actually change that, but the end result is that it has to be attached onto this bolt here solidly so that that connection cannot move. Because if there's a little bit of wobble in there, then that's going to muck up all of the readings that we take. So everything here has to be bomber, has to be super well attached. And of course, as the leg moves up and down, that will move the slider up and down. And you can see we've got just enough space to measure the entire length of the leg. And the cool thing here is that this will be useful for measuring that end position, but then to like zero the reading, we can actually move the leg all the way down to the side, take this same piece, and then run that down until it hits that ball. And once it hits that ball, we know what the diameter of this ball is. The radius is 12.5 millimeters. I will measure them all just to triple check that they are exactly 12.5 millimeters. So we'll know where this position is. We can offset that by the radius. So then we know exactly where the center of this sphere is. Then we can bring this guy up, straighten the leg out, and then attach it on. and then take the measurements. And then everything should be measured, all of the lengths, the homed length, like the shortest length that it can possibly be, will be measured with respect to this 0 position. And then all of the other readings that we take will all be measured with respect to that 0 position. So this is exactly what I wanted to have this whole time. Perfect. In theory. Yeah. There is, of course, the big question of, do I trust this linear slider to actually be correct? Which is a very valid question, especially because I bought it on AliExpress. So it's a bit like, But I think it should be fine. My biggest concern is that somewhere between sliding and taking the actual measurement, there are missed steps. So if, for example, so that would be a problem where, like, if we move fairly fast, then we might actually move like 200 millimeters, but because we've moved so quickly that something in the system can't keep up, then we might only record 100 millimeters of movement, which would obviously be a pretty big problem. I feel pretty confident that the actual measurements themselves are correct, because my understanding of what is actually inside these sliders is there's a big piece of glass that has lasered increments cut into it, or lasered into it, and those are, in this slider's case, they are 1 micron thick each, and then there's a light that shines through those gratings, and then there's a little photo receiver on the other side, and yeah, based on where if the light is blocked or if the light can pass through, we can tell if the thing has moved at all. Since that is on glass and since that's lasered, I feel pretty confident that the precision of that should be correct. I can and probably will also just take measurements with my my digital calipers, but these only have a precision of 0.01 millimeters anyway, so yeah, it's like I can only measure this to within 0.01 millimeters, which is 10 times worse than the precision of this quoted value. So let me turn that fan off. So yeah, overall, I think this is pretty good. So my biggest concern is that it will skip steps, and I think that should be easy to check for, where if I go through that entire process that I described before, so we move the leg out of the way, we bump this down until it hits the ball, we do it up, we take it up, we connect it on, we take all of our readings, and then right at the very end, I do that same start process another time. Take this down and bump it onto the ball. If I'm then reading 0 or whatever it was reading the first time, I feel pretty confident that the readings in between should be correct, because it's very, if we have skipped steps or missed readings, it's very, very, very unlikely that this will read the exact same that it did before. In my mind, the only real way that this can read the same thing both times is if it didn't skip any steps during that entire process. If it does miss steps in the middle, I guess that will mean that I'll have to do that run again, and hopefully it won't skip the steps a second time, but I'll have to cross that bridge when I come to it. I feel pretty confident that this will work pretty well, as long as I don't move the slider around super, super fast. Yes, so I'm just waiting on the aluminium extrusion to arrive, and then I should be able to put all this together and finally get these legs measured, and we can put the robot back together again, which will be very nice. Very, very, very nice. Also, if you're interested, I've got the board case in here as well, which is pretty fun to CAD. I was a big fan of this, and the Onshape link for all of this, so you can see everything that I've got in here. This is in the description, and so you can do whatever you want with it. Make one yourself if you want to. Whoa, what have I done? Yeah. Cool. So I feel pretty good that once I get this new extrusion, that it should all work pretty smoothly. And yes, the final thing for this week is that there will be no stream until the 21st of March, which is, I believe, 3 weeks from now. So no stream next week or the week following, but then there'll be another one the next week after that. The reason for this is because next week I'm busy, I'm away doing some stuff. But the week following, I've got... Now that I've been doing these streams more regularly, I am curious to take a week off and then see how I feel about, like, if I can like spend this Friday time actually doing work instead of doing the stream, and like preparing the slides and everything takes a while, making all of this wiring took a little while. Maybe I will be even more productive and like be able to get even more done. So I just want to like see how it feels basically to not have a stream for a week and see how we go. Also, because I'm curious to see if people have any suggestions on this. After a lot of thinking and like realizing how common this whole problem is of like wanting to read sensor data quickly without missing any data, and yeah, just like getting all this set up and like all this stuff about like not soldering the microcontrollers directly onto the board, all of that sort of stuff seems like a fairly universal problem that a lot of people have. And yeah, so I'm thinking it could be good to make a proper long form, maybe not super long form, but like a proper actual edited video on this whole process that we're going through now of like measuring the legs. So going through like all of the trials and tribulations that have come up along the way. Hopefully, fingers crossed, with the end result of the exact setup that I just showed you then working, and then we can show the before and after of like how accurate the platform can move around just for making that change without even calibrating the node positions or anything like that. So yeah, I don't know if you think that video would be, I don't know, useful for you or fun or entertaining, or if you would like it, then yeah, I would. Or if there's anything in particular that you would like to see about this process, then yeah, I am all ears. And so how this relates to the stream is that I don't think it's going to be a very interesting stream if I just talk about the video making process. I feel like that sort of stuff is, I don't know. I mean, maybe it is. If you would like to see a stream about where I like talk about the video editing process, let me know and I can do one. But I can't imagine it'd be as I don't know, engaging or informative as the rest of the stuff. But I could be wrong, so I don't know. Yeah, those are my general thoughts. As always, there's a couple other things. This is a quick stream this week. Yeah, damn. Yeah, but I wanna save the other stuff until a bit later. I've got some goodies cooking that are gonna be pretty fun. But yeah, I'll save them. Cool. That went by fast. Nice. Well, yeah, I will see you all in 3 weeks. Hopefully, by then, I'm sure the extrusion will have arrived by then, and I'll have it all. Hopefully, it'll all be done by then, and the row will be back together next time you see me. Fingers crossed. Yeah. Until then, have a good one. Good luck with everything you're doing, and I'll see you in a couple of weeks.